Hey everybody, this is the third and final installment in what I'm calling battery terracing. It's a way to rethink and reconfigure your battery for a lower center of gravity, which translates into a performance upgrade in climb angle and side hilling. The first episode was basic soldering on a LiPo battery to show you that it could be done and so you wouldn't be afraid. The second episode was a wiring schematic for merging two 2S batteries to perform and charge like it's a single 4S battery. Now I'm going to show you my final packaging, and hopefully this will give you some ideas for your rig. And the cool thing is, I will show you how to wire two batteries together so they perform and charge as one, and do it with only one additional solder connection. So I think I've got it figured out how I'm going to mount my battery. The first time I tried didn't work out so well. Let me show you here. So this was my first attempt that really had potential, I thought. What I had done here is put the battery in a square. So I took two 350s like this, and I wired them internally, and I didn't yet convert both of these 2S's to a 4S charger, but I did wire the battery input in one, and I charged the battery so I know it works, and consolidate it down to just one power output. So these two 2S's act like one 4S, and I shrink wrapped them together, so I made a really nice flat battery instead of a 4S is normally like this. And so I thought this shape was going to be perfect. So I got, I have room right here behind the steering servo. And if you recall from the first video, the speed controller and each battery weigh almost exactly the same. So it doesn't matter where on the front axle I put these. If I put two batteries back here, two batteries up here, speed controller back there, as long as I have them all on here, it'll be a win in virtually any combination. So now the question is ease of use and wiring. And so I thought I had a really great concept here. I cut out this U shape from a square, taped it on the top. I've got this strap running underneath it, and the battery just slips right in here like this, and it's held in place really nicely. Velcro over the top, really clean, nice and low, and out of the way. And I thought this was going to be a winner, but after I got this all designed, that means I have to put my speed controller up here somewhere. So the steering rod is going to be right here, so it gives me this area to put the speed controller. And I just ended up with so many wires up here. I've got 3 motor wires. I've got the rear battery power wire, the battery wire. These two go to each other on the front here, and all these have to go to the back. But I just had so many wires tangled up here in the front, and these wires also have to move when the suspension moves, that I kind of concluded that this isn't going to be the best way to do it. So I'm going to go back and try one more time. So let me have this taped on. Take that off. So as much as I thought this was going to work, I'm going to have to revisit it. Look at that. That was so nice and clean. So I think a better arrangement is going to be one here and one here. And I've already made this little carbon bracket to help position the battery. It'll protect it a little bit, but also just keep it in place. And this weighs less than 2 grams, so I'm not worried about the extra weight it adds. What I'm going to do is Velcro the battery right there. And the second battery, because remember I want a 4S, is going to be right here. Now, as promised, I'm going to show you how to merge these two battery packs with only one solder. Now these 350s are pretty good. They come with the XT30 connector that I like, but these wires are a little bit short. So I've been using these Ovonics batteries, but they're out of stock right now, so I couldn't get any more. They come with much longer wires that makes them a lot more usable. Another battery I like is this Gens Ace Adventure 400. These are kind of hard to find. I will put an affiliate link that you can click on to buy these from A-Main Hobbies, and A-Main will share a nice commission with the channel. These are really great. They're pretty much exactly the same size as these 350s and these Ovonics 380s, but they're claiming it's 400. Now, Gens Ace is probably one of the best battery brands out there. It's entirely possible they have better chemistry and that this is a 400 milliamp hour battery. Hard to say. I don't really have a good way of measuring what's written on the batteries. I will figure that out eventually. But if these are really 400, this is the smallest 400 I've ever seen. Now, this does not have the correct connector, but that's okay. It does have nice long balance port connectors, so this is a great battery to work with. So I'm going to put one of these here. And the second one here. And that's going to make a 4S battery that's half the height of a 4S battery. And I'm going to put my speed controller right back here. That'll be a really nice bundle, everything on the front axle. I did rewire my speed controller a third time because I wanted these wires to come off yet another direction. I keep changing my mind. But what I did this time is I reduced the size of these wires from 16 gauge down to 18 gauge. So the motor wires are smaller, and the reason I did that, because the wires on my motor are also 18 gauge. There's really no reason to have your wires be half thicker 16 gauge and half 18 gauge. So these will all be hardwired together, all the same gauge. And on the battery side, I put smaller wires here as well. These are also 18 gauge. This Beekeeper ESC came with 16 gauge. Remember, the smaller the number, the thicker the wire. So 18 gauge is a smaller wire. And I did that because, well, my batteries all have 18 gauge wires. There's no point in having thicker wires here if the battery has thinner wires. So I put thinner wires on my ESC, which is something I might recommend you consider as well. Now, I have to assume that both the battery maker and the motor makers have selected wires that provide sufficient resistance or lack of resistance, and that the ESC maker was just being on the safe side by putting the thicker wires on. So we're going to have this here, here, here. I will put a connector on this. These will go to the motor. This is going to run right to here. This is going to be really nice, super compact. All right. So I'm going to build a bunch of these batteries. They only last about 15-20 minutes, so I'm probably going to want 4 to 6 batteries total for half a day of driving. And if that's not enough runtime, I'll charge them at my car in the field while I'm running down the latter ones. But I think 4 to 6 battery packs should be enough for me. I know some of you guys run much longer, but that's about the time I put into it. So let's start by removing all these labels. this Genzace 400, I did find some on Amazon, but your best bet is to go to A-Main Hobbies. And A-Main Hobbies is probably my favorite online hobby store. They really support the hobby. They're also into bikes. They own Dan's Comp and a few other bike-related companies, and they do a great job. Their customer service is terrific. I probably buy maybe a third of my stuff from A-Main Hobbies, and the other 2/3 generally comes from Amazon if I can't get it directly from the manufacturer. Now this here is just a plastic protector. I don't know if this is maybe a code in some countries, but it's largely unnecessary. Just take a screwdriver and pop it off. Remove at your own risk. I'm sure it's on here for a reason, but these are like the only batteries I've ever seen that have this cover on it. Most batteries just come like this. Now I need to see what's going on the inside, so I'm going to very carefully cut off this shrink wrap. Yes, I have punctured a battery before. Be super careful. This is actually my most feared part, is tearing this off. So if you cut down the side right here, there is a little seam between the batteries that you can cut in that might be safer. Kind of hard to find it. I'm just going to go right here, but I'm going to keep the nose of the scissors up. All right, looks like there's some tape underneath here. So what I'm going to do is place one battery like this. What gauge wire is this? This is a pretty small gauge wire. This looks like it's, this is really hard to read. I don't know if this is 20 or 22 gauge, but this main power lead is 1 or 2 gauges smaller than what you normally see, which is 18 gauge. I don't know if that'll be a problem. Crawlers don't really dump a lot of amps fast, so if this is a problem, I could replace this whole thing with a different plug, but I'm going to use these tiny wires to start. These Ovonics batteries do have the thicker power leads. But since I couldn't get any more Ovonics right now, I'm going to try this 400. So let's see what's underneath here. Well, I got a pretty good idea what's underneath here. It's not going to be a surprise, but we're not going to need this. Here's that slit on the inside. I said you can sometimes cut down along this slit and reduce your exposure to puncturing the battery when you're using scissors in the vicinity. All right, so I got lots of wire underneath here, which is good. There's a little piece of foam here. I might preserve this foam, although it's pretty thin. All right, so all my wires are available. Let's see what's going on here. All right, so the first thing I want to do is figure out the best way to have my wires come off. So again, I'm going to make this Z shape, I guess. And I want all my wires to kind of come out in the middle here. I think there's enough here. I can just make a loop like this. And a little loop like this. That avoids having to do any soldering on the battery. All right, so I'll just pull these tight. All right, so I've kind of snaked these around. All right. So ultimately these are going to be packaged about like this. Maybe 10 to 15 millimeters overlap. All right, let me try to do a structural taping here. Okay, so that's going to be the final shape. This battery's inboard, this battery's outboard. And what I need to do here is start to consolidate these wires. So first, I got these guys here. So I'm going to start with the red wire off of this battery. And the black wire off of the second battery. All right, so these two are going to be my connector. Now I will have to change this connector to an XT30. That will require a solder. I know I said I was going to do this with only one solder. I'm going to cheat a little bit. I'm not going to count that because virtually every battery pack I've ever had, I've either lengthened or shortened the main power lead or changed the connector. So that's pretty much 2 solders you're going to do anyway. So I'm not going to count those 2 against my total solder count. And so if you feel like I cheated or misled you, so be it. It's only going to take one solder after this to rewire all of these remaining connectors. So I'm just going to tape this together for convenience and so I don't accidentally make contact on anything. All right, so this will be my ESC battery connector later. So now I've got this mess to fix. The first thing I need to do is connect this red to black. That's going to take a 2S and make it a 4S and make the output at this eventual connector a 4S. So these two need to be connected. Just to recap, we're starting with 2 2S batteries, and you cut off one black and one red wire from the main power connectors, then combine those into one connector of your choice. Personally, I like the XT30, the yellow ones. Then connect the remaining red to black. This now gives you a 4S output. This is called batteries in series, and the voltage goes up to 14.8 volts nominal. And I'm going to hold these out of the way. All right, so let's see where this black one goes. The black one actually just goes right here. So I could just solder these two together and call it good, but it'll be cleaner if I connect this directly to the battery. Okay, so what I'm going to do is solder this red one to this spot right here. Let me start by taking this one off. Now I might lose this black one in the process. That's okay, we'll be sure to put it back. All right. Now, I'm gonna cut this one nice and short. Strip a tiny bit off of this. Use the right hole, 18 gauge. All right, I'm going to pre-solder this. I'm going to hopefully just push this All right, I think it's my lucky day. Okay, so that red one is the one and only solder joint I'm going to make. So I'm going to insulate that with a little bit of tape, because that's how it was before. Now I'm going to do a little structural tape over the top. All right, so we've got a black and red for the main connectors, and what we're going to do now is merge these dual 2S's into a single 4S connector. Now originally I feared I was going to have to solder on a 4S to all the locations to make it work. And then something occurred to me, and many of you can probably already see where this is going. I bought a pack of blank connectors, and I'm just going to unplug all these and plug them in to a wider one. The key is just to do it right. So that's how you avoid having to resolder anything. You just change these connectors. Now, if you follow the map, you're going to want to very carefully follow the diagram that I put up previously. Next, we have to manage the balance connectors. All you do is connect number 1 from the second battery to position 3 on the first battery. You can connect it anywhere along this line, from the plug down to the battery terminal or anywhere in between. Then the second connector becomes 4 and 5, and you simply combine that into a single 4S connector, being sure to keep the order exactly the same. So this is from this battery, and this is from the other battery. So let's just start by changing these 3. Now, there's 2 ways to get these out. You can simply push on this tab and pull it out. However, I've ended up damaging that tab to where it couldn't be used and had to replace this wire altogether. So I've got a better way to do it. Since we're not using this plug, we're just going to cut it out altogether. Look at that. Totally undamaged. I've still got the hook on it. So that came out of plug number 1, and we will put it back in plug number 1. All right, so that just goes in here. Boom! Ready to go. Now I'll take number 2 and put in number 2. Trust me, this is a lot better than pressing on the tab and risking breaking it. There we go. Tab still intact. It's number 2. Beautiful. Now we'll do number 3. Now sometimes you might want to lift this tab up, just bend it up a little bit to make sure it's still nice and sprung. But if you didn't damage it on the way out, it should be good. All right, yeah, those are in there nice and tight. Okay, now this is just where you want to make sure you are keeping your accounting correct. This red one gets connected to this black wire. So I'm going to do that one last. Let me start by putting these 2 on the outside to the outside. All right, check that out. Now we've got a 4S plug. And when I put my connector on here, this will be the main power lead, and this will be the balance charge port. Now, some of these wires are a little longer. That's okay. Twist it up. You'll never even notice. But the question remains, I have this red one. Now, this red one has to be connected to the middle black one. So let's see where that middle black one goes. And if you follow it carefully, that middle black one is amazingly the one we just soldered this red one to. So we already have a red lead, this one, going to here. We don't need this one at all. So I'm going to cut it off back at the base. When I first did this, I can't tell you how excited I was to realize there's already a red connector that we just soldered that goes to just the right spot. So there's no need to have this one. And if you don't believe me, we will charge this and see what happens. So this guy right here is not needed. We will just get rid of that. If you look at the two prior diagrams, you will see this connection on both of them. This is why you don't have to connect two wires in real life. Just one does the job. Here is the full final schematic, which you can screenshot for future reference, or it will always be here. So before I protect this whole thing, we should make sure the wiring's all successfully done. So I'm going to go ahead and put on an XT30 connector. There's a lot of ways to strip your wires. I prefer to do it the right way with correct pliers. Got this really cool soldering doodad from Amazon. Magnetic base. Let's see if this will help us here. Make sure I put the right one. Red's positive, goes on this side. Now you can usually rotate these plugs so they're in the most convenient location for whatever direction you're soldering. So I'm just going to turn them all up. Nice. Wish I'd have bought this many years ago. Wow, that was easy. Now, just for safety, I'm going to do the shrink wrap up now to reduce chances of short circuiting. Okay, so it's all consolidated. All the wires are consolidated. And let's check to see if it's been wired correctly. So the first thing I want to do is make sure that these are all correct. So full voltage should be 15 volts probably. Great. Now what really matters is if we got these all right. So if we measure across the whole thing, it should be full voltage. 15.3, great. Now, if we measure across just these two wires, it should be, I don't know, 3.3 or the voltage of one cell. 3.8. So this would be 3.8. These two, 3.8. And these two, 3.8. So yeah, each of these paired connections measures across one cell. And the outermost is across the whole pack. That's how your balance charge works. your charger will look at each cell individually and make sure they're all about the same voltage. So we're in good shape so far. I am going to do one more test, make sure, just to make 100% sure that it's correct. Plug this in. Cross your fingers there's no sparks. All right, it's charging. I think I did it right. Here you can see the voltage of each cell, 3.8, exactly what we just measured. And the charger will make sure each of the cells get charged at a similar rate to keep them all at the same amount. Now, this looks like it takes a really long time, and your first time may take a bit. But when I'm not explaining as I go, I can do this in less than 5 minutes, so it's not nearly as burdensome and time-consuming as it may appear. I'll have 4 or 6 of these batteries knocked out in less than 30 minutes, and that'll keep me running for many months, or until the next time I decide to change the layout again. Now, I don't like looking at the silver parts of the battery, so I'm going to wrap this in black tape. Now, I don't mind using a lot of tape because every layer of tape is more protection. I'll probably go around this way twice, partially so it's blacked out. So I've got some structural tape underneath. This black tape is for insulating purposes. It's not very structural because it stretches, but it does insulate and add some padding. Okay, now the next challenge is going to be shrink wrapping this odd shape. Now, if you've watched my other videos, you'll know that I made a big deal about using a special marine grade shrink wrap. And I still recommend that if you're doing just one cell. Marine shrink wrap is extra thick. It's a 3-to-1 shrink rate instead of 2-to-1, and it's really thick. And it also has an adhesive, so it seals up the ends and kind of sticks down. So if you're just packaging one cell, I definitely recommend marine shrink wrap, and I'll put links in the description. But for this, because it's an odd shape, and because I've already got quite a few different wraps on here, I'm just going to use regular shrink wrap. I think that's going to be easier and better for this application. Now I'm going to get a little creative with the tape here. I'm going to do it at an angle. All right, now I'm going to take a piece and put across both of them. This is a 30 millimeter, says right on it. All right, now because I like to be extra safe, I'm tempted to put one more piece around this, like so. I think I'm going to do it because that marine tape is really thick. It's 2 to 3 times thicker than your more common tape, shrink wrap. I think this is 35 millimeter. So I'm just going to put one more strap across here. Maybe that's too much for most of you. Well, I've still got an empty spot right there that's kind of bugging me. Well, I think I've probably put enough time into this, and I think it's protected well enough. Batteries don't last forever. Let's do a final test fit here. Nice. Now I thought maybe I would need some sort of retention up here to hold it in place, but that's pretty secure. That's not going anywhere. I think I'm gonna run it just like that. You know what? I think I'm gonna redo it to make sure that little corner is covered, but I won't bore you with that. I think you've seen enough paint dry for one day. Here you go. Here's the concept. Battery terracing. Instead of having a big ugly 4S up here, I've now got it set down here, half the height that it was. So there you go. Hope this gives you some ideas on how to terrace a battery for your application.